So yeah, my name is Rafa Porres. I'm the infra lead here in Sourced. I'm going to talk about how we provision servers in here. So, like a year ago, we decided to go bare metal. We had all our servers in Google Cloud, basically due to some grant that we were given, some credit. But in the long term, we really felt and we started making numbers, and we really thought that it was a much better idea to go bare metal. But once you start going that route, you start to think a lot. You start to pose yourself a lot of questions, because we are quite we've been accustomed to do certain things in the cloud that you cannot do anymore, or you have to really think very well how you're doing. For example, scaling. Now, when I'm asking for a new server, I can have it in a day, but maybe I cannot have it. Not that one that you want is not going to happen. So scaling is not only because you cannot just ask for a bigger server and go automatically. It's because sometimes you don't have the servers when you go in bare metal. And of course, you're less flexible. You have to, the investment normally is higher, because everywhere, every bare metal provider is going to ask you to pay upfront a month, a couple of months. That's very useful. And you cannot buy just a small instance, do your demo, and then, well, move on. That's not going to happen. You have to go back to some technology that you haven't touched for a while, like installing, like TFTP, like iPXE, things that myself I hadn't done since I was installing Solaris. So, yeah, and you really need expertise in those technologies that normally the developers are very allergic to. So you really need a DevOps team for that. So, yeah, why we decided to go bare metal? Basically, that's the difference from 100K to 20K per month, and you really have powerful servers. You don't have those AWS CPUs that, well, sometimes they perform, sometimes they don't, and you exactly get what you get, like 128 gigs of memory server with like cheap, and it's cool. And of course, one of the risk of going AWS is that you have everything there, and the moment that you want something, hey, it's there. I don't have to do anything. But it's the risk of vendor logging is quite high when you're going into a cloud provider. So once you've decided that you want to go bare metal, you have to install it, and that's one of the first things that's tough, because you have to go back to relearn or to refresh what you used to know about DHCP, about PXE, iPXE, how you are going to deliver your OS, how you're going to configure. If you have different kind of servers, you need different roles. For example, you may have some. In our case, we have Kubernetes masters, Kubernetes workers. We have other servers that are doing different stuff. So definitely you are going to be needing all that normally, at least myself, I hadn't done for a very long time. What's the good news? The good news is that in our case, we are using CoreOS, And the reason behind is that we are running everything in Docker, and we are running everything on top of Kubernetes, and all the match is quite good. If you're running containers, going CoreOS makes a lot of sense. So, and the other good reason is that CoreOS provides a lot of interesting tools to make your life much easier when you are dealing with these things that we are talking. For example, they have a very, very cool project that's called Matchbox, which is what is going to help us do all those role-based booting and configuration. It allows you to select what kernel is going to be loading every server and what configuration is going to be delivered. And that configuration is going to be delivered through Ignition. Ignition is a very, very cool project that basically what it does, it copies files in its ramifest time so that before the first process is up and running, you have everything you need there, and you have all your partitions, you have every systemd unit that you need, so that your operating system boots. And the other piece that is very important here, as we saw before, is the Dhcp server that is able to deliver the first instructions of how you're going to be booting your servers, and that is be able also to deliver the kernel files via TFTP, and also it can provide you a bit of DNS. And the guys from CoreOS, they have this wonderful DNS mask container that not only contains all the binaries for DNS mask, but it contains the IPXE images that you need to start the chain. So a bit of recap of how this worked. When this is the most normal thing that you're going to find. If you have different servers or you have more modern servers, you may have different stuff, but this is the most standard thing that you are going to be needing. First, the server issues a Dhcp request asking for, hey, I want to boot. How can I do it? So the Dhcp gives that file, and the good thing or the interesting thing about that file is that it's the one that is going to be enabling the process to be managed by IPXE. The interesting thing about IPXE over PXE, it is that it can go through HTTP, and this is going to help us a lot to pass those characteristics of the servers that are going to allow us to target specific images or specific profiles whenever we're booting. So the first thing that is happening is that our DNS mask gives that file only IPXE that basically says, hey, this boot process is going to be managed by IPXE rather than PXE, and that is very interesting, and that's the most practical thing if you want to do the kind of things that we need. So once that file is delivered, the boot is controlled by IPXE that requests to Matchbox this boot IPXE file, and there's a whole transaction of IPXE files that are going to basically give more characteristics of what we exactly want until our Matchbox server delivers the kernel images. We can see that after in the demo. So, Matchbox, what's the good thing? I think it's much better to see this nice picture that I've stolen from the guys of CoreOS. The idea is that you have three basic things in Matchbox. Groups that define groups of servers or just one server based on selectors that you can define. The most straightforward and the most used and the only one that I use is the Mac. So, hey, I'm receiving an IPXE request with that selector. Hey, great. And then the next thing is that group has a profile, and that profile defines these parameters, which kernel, which initRD, which kernel args, and the last thing, which configuration template for Ignition is going to be loading. And then once CoreOS has booted, and one of the arguments that is passed to the kernel is where to get that Ignition file, then we can configure and we have everything that we need. The other thing that Matchbox, of course, provides is assets. Assets are these different kernel images that and initRD images that are used in the different servers that your fleet is composed by. The interesting thing about Matchbox is that not only can be configured manually, writing those JSON files yourself and those templates for Ignition yourself. The good thing is that those files can be delivered via a gRPC endpoint, and that's exactly what we are going to be using in Terraform. So when we started doing this, we started doing it manually. We're creating those JSON files manually, but we are transitioning to control everything that we do through Terraform. And you can think, wait, but we are not in Terraform. You are creating resources. Whenever you define your Terraform files, you say, hey, I want that server, I want that, and Terraform issues, for example, an EC2 command, an EC2 API call in order to create that resource. But there are different providers, and there are providers in Terraform that basically what they do is to create configuration that will be used. And this is exactly what it does. So, I've skipped a bit. The idea is that we are going to be sending via that gRPC endpoint the configuration for Matchbox that we need. Those groups, those profiles, and those Ignition files that are going to define how the server boots and which system D, with partitions, which users, whatever you can think. So, how many of you are familiar with Terraform and have worked? Okay, no. So basically, the first thing that you do with any provider is to define a series of parameters to connect to it. And basically, here what we need is the RPC endpoint for Matchbox and some credentials. When we are defining a group, basically we give that group a name, we define a profile that is going to be used. The profile, as just to remember, is the one that knows which kernel images to deliver, which arguments for the kernel to apply, and what configuration file, what ignition file you have to deliver. You can define a selector. There are more selectors, but the only one that we're using and the only one that I find useful for the moment is the Mac. And there are more things that you can add here, depending on how you use how you use ignition, and you can define some kind of metadata that can be passed to ignition if you're using ignition templates. We're not using ignition templates. I will go back to that afterwards. We are using the Matchbox Ignition in a rather peculiar way, and I will go through it a bit after, because it makes sense when you know more. What do you have in a profile? As you basically define which kernel is going to be delivered, and the arguments, and this raw ignition. Basically, it is the result of the ignition provider that I will be explaining afterwards. The idea is that an ignition file can be a JSON file that has a lot of information of how to boot your system, but it can also be a YAML file that contains that same information in a more readable way with placeholders for that metadata that you can give in the group file. The idea is that we are not using that because when you try to modularize a YAML file, and when you have like 3-4 different kind of servers that are very similar but a bit different, you end up repeating yourself a lot, and it's quite difficult to put that in a Terraform context. So with Ignition, what you can do a lot of stuff, and the idea is that you define in Ignition how your system is going to be booted, and how, in this example, you see that I'm defining all the network D units and the users, but you can also define systemd. You can also define systemd units. You can also define how you partition a disk, how you format it. You can create any file that you want. You have to take into account that this is done before the system is running, so you avoid a lot of problems of how you configure your network, for example, because it's done before that. We are using Ignition here to boot Baremetal, but you can use it, and it's used for example, in AWS. You can, if you boot a CoreOS server in AWS, you can put an Ignition file in the user data, and it will get it, and it will define how it is booted. Normally, as I said, it is written in YAML, but whenever that information goes to the server, it is transpiled to JSON. And what we are not going to be using is that templating system, because what we are doing is directly using a Terraform Ignition provider that is creating that JSON file for us, and we deliver that JSON file to the profile via this raw ignition parameter for the moment, I'm saying a lot of things. If you have any doubt, if you want to stop me by any chance, just do it. So those assets, basically, you load it manually. You load those files that we need to boot the servers via a script that CoreOS provides. But you do it. There's no way of doing it in a way that's not manually. So let's take a look to how this works. For this demo, it would be excellent to have something like Raspberry Pis or stuff like that in order to have real bare metal, but it's going to be easier, and it's cool to play to use VirtualBox. All the files, everything that's there is in my GitHub repo, and all what you need to configure the server that is doing all the Matchbox, DNS, everything is there. So what do we have here? So here we have a server that's basically running DNS mask and Matchbox. That DNS mask, basically what it does is it has information of how to boot. So whenever, so one of the differences that we are going, that from this demo or from what I've explained is that I'm going directly via iPXE, because enabling PXE in VirtualBox has proven to be too difficult. And what I'm using is a CD-ROM of that the iPXE guys give you to test, so that you go directly iPXE. So whenever that Dhcp request arrives, I say, hey, go to this URL to get your information, and it's going to chain load, and it's going to do another request with all this information that is interesting to us, and that information is exactly the selectors that we can use in Matchbox to target exactly how we load every server depending on this information. And the rest of the configuration is basically how some DHCP records and the DNS records that we are going to be using. The other thing that we have is Matchbox. There's no. That the only thing, the interesting thing it does is that it reads everything from this Matchbox directly, in which I've already loaded the Terraform files that you can find in the repository. So the last thing that we can do is, for example, is to okay. So if you see this server, for example, and you go to where it is? Yeah, here. In the optical drive, you see that I'm using that iPXE image that I need in order to boot this. So if I start it, it will get that. So if we go back here, the first thing it does is what I've told you after the DNS after the DHCP request, it gets that IPXE image, and then it goes and asks for that chain load. What it's going to give you is this kernel, and in it there are the files that we need, and then after that the ignition files. So let's take a look to how this looks like in Terraform. So in Terraform what I have is this I'm not going to give you a lot of details because the example is a bit convoluted because I want it to be useful, so it's not straightforward to follow. But the idea is that what I do in Terraform is define a module that gives you all the characteristics that a certain host have, and the only thing that you have to give it is a few parameters, which are different for each one. So you have to give it a host name and the MAC address, and this parameter will see it because I have more servers that I can boot and they can form a cluster. But the idea here is that these modules, that first you have that Matchbox that has that provider that I told you before, that resource, that Matchbox group, and that profile, and this the raw ignition is basically the ignition file that you are going to be delivering. So what does it look like? For example, at the end. So basically, it is a YAML file that has the contents of the network units, how you're going to. You can give files that you want to pass, for example, the host name, or you can give system units. So when you not yet. The idea is that an ignition that ignition config is based on different parts, different units that you can put one after the other, that configure the different the network, the users, the system D units, whatever. The idea is that instead of putting in a monolithic way, what you can do is create another module so that it can be reused across different host types that you want to boot. Okay, let's boot the other two. Let's take a look. Okay, so if we take a look to that DNS mask conf, we have the different IPs of the servers that we are going to be booting. If we take a look to the ignition, we see here that we are going to create one user. Ignition users. And this is how it looks like, these users that we're creating. It's called demo. And I've copied the corresponding key, private key here so that I can, okay, so if I do, and if as I have, there are two more servers up and running that have everything that we need. And this is it, more or less. I didn't give you many details, but because everything is in the repo. But you feel free to ping me for everything that you don't understand or whatever from that repository, or if it doesn't work for you or whatever.
We have evaluated Tectonic as an alternative to mounting every piece by yourself.
6,000 euros per server.
So yeah, I would love to. Tectonic looks really, really cool and really interesting, but when you are planning to deploy 100 servers, you say, oh, maybe I will do things by myself, by ourselves in this case. We would love to. It could be cool to use Tectonic, but it's a bit out of the scope due to monetary restrictions.
Thank you. Do you think that things could change after Red Hat has evolved CoreOS and so?
That's a more philosophical question. Is Red Hat good or a good guy or a bad guy? Don't know. It's a bit out of topic. My impression is that he's not that bad, such a bad guy. They've acquired a number of open source projects that are still open source and are still usable, and I'm meaning things like cluster or Ceph. And why not? He's not going to be a good guy with CoreOS. Even Oracle is not such a bad guy at the end. Because we are still able to use MySQL, and after everything that was said, all the nightmares that we were told that we were going to have, the truth is, for example, is that MySQL is much more usable than MariaDB, for example. So why not a big company is not going to be doing a good work with an open source project? That depends on the project and that depends on the company. I think Red Hat, why not? I think we should give some confidence.
I don't know if there was any news about that or something.
Not that I know of.
Okay.
Hey Rafa, thank you for the talk. It was really good. How long have you guys been running on Baremetal versus the cloud? Obviously, you have a good reason for saving money. How long have you been doing it?
More than a year.
A year. Okay. That's a lot of savings in a year.
Yeah, and one of the interesting things is that it really gets you back to things that you kind of forgot, and that are very particular to our craft. So you really feel like an old timer at times.
How long does it take to provide, like, since you decide to buy a node, like, you plug it in and it's available as a Kubernetes worker, for example? How long, like, how does?
That depends on how long it takes the provider to give you the server, and once you have it, it's minutes. The moment that you the moment that you configure that you add your stuff in Terraform, The one that the only problem is it is a new role that you have to work more in order to provide to build how it looks like. The moment that you add a new one, you just create the configuration, and it goes to the Matchbox server, and then you boot it, and off you go. Okay. So